Hello, Algebra 2 people, and welcome to week 3 of our online learning. Today, we're going to look at adding and subtracting fractions, everybody's favorite fractions. And so let's dive right in. We will have 2 assignments, by the way, this week. So make sure to stay on top of your assignments. Don't forget to get them done. To add and subtract fractions, we're going to have a common denominator. The denominator is the number that's in the bottom of the fraction. So just some vocab to remember. The top number is called the numerator. The bottom number is called the denominator. And when we add our fractions, we just need to make sure that this bottom number, the denominator, is the same in both fractions. When it is, we can just add the top numbers, the numerators. So we're going to add 3 and 4, and we get 7. And the denominator stays the same. So 3/5 plus 4/5 is 7/5. Okay? Now the same can be done with algebraic fractions. That's fractions that have variables in them. If I had 3x over 5 plus 4 over 5, again, as long as the denominator is the same, I can just add my numerators. So 3x plus 4 is what's on the top. By the way, that is not 7x, because 3x plus 4 is still just 3x plus 4. It's not 7x. That would be crazy. And the denominator remains the same. So when you add 3x over 5 plus 4 over 5, you get 3x plus 4 over 5. Yay! Now, earlier I said, when we add fractions, the denominator needs to be the same. What if it's not? So here's a case where we have 3/5 plus 4/10. The denominators are not the same here. So what you have to do is you have to think, how can I get my 5 to be like a 10? And the way we do that is we'd have to multiply 5 by 2, wouldn't we? So I'm going to think about this fraction over here as 3/5 times 2 over 2. Now, some of you might be saying, why? And just like before when we were simplifying fractions, we could divide both the top and the bottom by the same number to simplify. We could add, I'm sorry, scratch that. We could multiply both the top and the bottom by the same number, and we'd still have an equivalent fraction. We just changed the numbers. It's kind of like unsimplifying it. But notice if I took 3 times 2, I get 6. So when I multiply, remember how to multiply, just multiply across. 3 times 2 gives me 6. On the top and on the bottom, 5 times 2 gives me 10. So you see, an equivalent expression to 3/5 plus 4/10 would be 6/10 plus 4/10. They really have the same meaning. And now, since the bottom number of my denominator is the same for both of these fractions, I can just go ahead and add. So adding the numerators, 6 plus 4 is 10. 10 is going to stay on the bottom because that number doesn't change, and they get 10 over 10, which, by the way, is, it's just 1. Okay? So let's take a look at how something like that might look in an algebraic fraction. Suppose I had 3x over 5 plus 4/10. Again, just like I did before, I'm going to multiply by 2 over 2 because my 5 in the denominator needs to be more like a 10 because my denominator needs to be the same. So I'm going to take 3x over 5 and multiply it by 2 over 2 and then add to 4/10. Again, I'm not changing the value of this fraction that's over here. 3x over 5 is going to be really the same or an equivalent fraction when I multiply by 2 over 2. 2 over 2 is just 1. And when I multiply by the number 1, it doesn't change the value. So let's go ahead and multiply. We're going to get 6x over 10, still plus our 4 over 10. Now that we have the same denominator, we can just add the numerators. So 6x plus 4 is going to be on the top. And our denominator stays the same. It's just 10. But now I want you to think about, can I simplify? We've talked about simplifying before. Is there a number that is common to 6x, to 4, and to 10? And the answer is yes. We could take a 2 out of each of those. In other words, I could take 6x and divide by 2 to get 3x. I could take 4 and divide that by 2 to get 2. And I could take 10 and divide by 2 to get 5. So when we add 3x over 5 to 4/10, we should get 3x plus 2 over 5. Okay? Let's move on. Let's look at another problem. Notice in the previous problem, our variable was in the numerator. What happens when it's in the denominator? Do things change? Let's find out. Sorry, things were looking fuzzy there. All right, so I don't have the same denominator, do I? So the common denominator, or the one that could be the same for both, would be if I had a 5a, because I have a 5 here, I just don't have an a. So I'm going to go 3 over 5a plus 4/5 times a over a. In order to get 5a for this, I'm going to have to multiply 5 times a. And so we'll multiply by a over a. And that gives us 3 over 5a plus 4a over 5a. Right? We just multiplied 4 times a and 5 times a. And that leaves us, when we have the same denominator, we multiply, or we now can add our numerators to get 3 plus 4a over 5a. Okay? Yeah. That would be our answer. Ta-da! Let's see how this works with a fraction where we don't have anything in common in our denominators. Like here's a 5a, but over here I have a b. Well, I don't see anything in common. Before I could look at this and say, well, I had a 5a here and I had a 5 here, so they both had 5s, and the only thing I needed to do was maybe multiply this one over here by a. But when I look at this one, I have a 5a and then I have a b, and so they don't seem to have anything that's kind of the same. So that means I'm really going to have to multiply both of those terms by something. So what would the common denominator be here? Well, I'm thinking I just have to have 5 times a times b for my denominator. So on the first one, I'm going to take, to get 5ab as my denominator, I'm going to have to multiply 3 times b, aren't I? If I multiply the bottom by b, I have to multiply the top by b. That's the only difference. 5a to 5ab is just I multiplied by b. What do I have to multiply over here? If I want to have 5ab from my denominator, what would I have to multiply times b to get 5ab? Yeah, and I'd have to multiply by 5a, wouldn't I? So on the top, I'm going to do the same thing. I'm going to say, okay, this is 4a, but I have to multiply by 5a. because what did I have to multiply b by to get 5ab? I had to multiply by 5a. So whatever you do on the bottom, you got to do on the top. So I'm going to multiply the top by 5a. So let's see what we get for that. We're going to have 3b over 5ab plus 4 times 5 is 20, and a times a is a squared over 5ab. So now they have the same denominator. When we have the same denominator, we can just add the numerators. I'm gonna do this a little bit backwards since I like putting my a squared terms first. I'm going to have 20a squared plus 3b on the top, and on the bottom 5ab. Okay? Now once we get there, we can say, do we have anything that's in common that we can cancel out? And we don't. Even though 20 and 5 both have 5s in them, the 3 doesn't have a 5 in it. And so all 3 of these terms would have to have something in common in order to cancel them. Just like, there's an a squared here and there's an a down here, but you can't cancel them because this term over here doesn't have an a. And again, all 3 of these would have to be having something in common, and they don't. So we're good. That's our simplified form. Okay, let's take a look at how some of this works on Manga High. So we're going to come in here. Oh, move me. I got to move me out of the way. Move me. Skill level, going to start on easy. Let's play. Which is equivalent to this? Well, if the denominators are the same, we can just add or subtract the numerators. So I think we're just going to get 7x minus 5 over 12. Yeah. Is the statement below true or false? Well, the denominators weren't the same. I'm going to have to change this one over here to an equivalent expression with 8 in the denominator. How do I go from 4 to 8? We'll have to multiply by 2. So I got to multiply the top by 2. So 1/4 is going to be 2/8, right? So we're going to get 3x minus 2 on the top and 8's on the bottom, right? So I think that that's true. Groovy. Evaluate 5/6 minus 3/4. Well, are these numbers the same? No, they're not. Is there a number that they both go into? Got to think about our gazintos. Is there a number they both can go into? And yeah, 12 is something that they can both go into. So think about it. What do I have to multiply times 6 to get to 12? Got to multiply by 2. So what should we multiply the numerator by? If we multiplied the denominator by 2 to get 12, let's multiply the numerator by 2, and we'll get 10. Ruh-roh, raggy. And here we got multiplied by 3, didn't we? So 10 minus that, that's going to give us 1/12, isn't it? We didn't go fast enough. My timer expired, and it's not going to move me on. 1/12. That was correct, but it's not giving me credit. All right. Again, these aren't the same. I don't know if I'll write everything out, but instead of a 4 down here, it's got to be an 8. So I have to multiply the top by what? Yeah, multiply by 2. So 3x times 2 is going to give me 6x, and 5x plus 6x is 11x, but it's going to be over 8, not 4. Boom. Simplify. These numbers are not the same, but I could get a 6 over here if I multiplied by 2. So we'll multiply the top by 2 to get 8. And what's 5x plus 8x? 13x over 6 is what they said. Which is not equal to this. Well, let's find out. This one here, if I multiplied the top by 2x, that would become a 6x squared, and that would become an 8x. This one here is just the same. This one here, what would I have to put on the top? We got to multiply by 2x. And if I did that, the bottom wouldn't look like that. So I'm going to say this wouldn't be equal. That's not the same. What's my common denominator here? Yeah, I think I can multiply this one here by 2, and I'd get this second one, wouldn't I? So if I multiply this numerator or denominator by 2, I'd get 2x plus or minus 6 rather. And then if I multiply this bottom by 2, got to multiply the top by 2 to get 8x. And 8x minus 3x is 5x. And on the bottom, we get 2x minus 6. So let's pick this one. Simplify. What could we multiply this by to get this? 3, we said. That's good. And so if we multiplied the top by 3, we'd get 3 times 4x is 12x. And 12x minus 4x would be 8x. Again, I think we can multiply this front one here by 2 to get that one. So 2 times 4 is 8 plus 1 going to give us 9. Uh-oh, extreme. This is our last question. We could multiply the bottom by 2 to get this one, couldn't we? And so if we multiply by 2, we get 8x minus 6. So 8x minus 3x would be 5x, and 6 minus 2 is 4. So what did I say? 5x minus 4? Is that what I said? I think that's what I said. Groovy, we're already on. We're already done. That was good. That was good. All right. Remember, you're going to have another assignment this week, so don't think you're done yet. Look at Riley. He's really good at this. He's already done this. Go ahead and do more, Riley, even if you have done this. Make sure you're following along. Watch the videos, darn kids. You know, I spend my time making these videos, and then you don't watch them. Go ahead and watch them. Watch my ugly face for a little bit. You'll be fine. All right. Good luck this week. This assignment should be due on Wednesday, so spend like Tuesday and Wednesday working on it and then turn it in. You'll have another assignment that will drop on Wednesday that won't be due till Friday, but don't forget about it. All right. Good luck. Stay safe, and hopefully we'll see you soon.